welcome back to all my dear students and friends. I'm Rabinshu Sharma, Assistant Professor in Department of Journalism and Mass Communication of Babu Banarsi Das University, Lucknow. So students, in my last video lecture, I have discussed with you about the topic radio format that covers the various kinds of formats like debate, feature, report, jingle, panel discussion, radio documentaries, radio drama, music on radio, simple announcement, talk shows. We have also discussed about the radio interviews, radio discussion, radio phone-in programs, and radio news, and various key characteristics of these formats. So I hope you must have got the idea about the radio formats and what are the things that you have to keep in mind while choosing a radio format if you're planning a radio program. So I hope you must have liked that video. So today in this video I'm going to talk to you about a little bit technical things about the audio format. Yeah, the things will be a little bit technical. We'll be talking about the audio formats in this video. If you are not a technical person, then you don't need to worry about all this because we are not going to talk too much technical. We will be talking a little bit technical things because this concept is about the audio format files. But yeah, there are a lot of formats about the, you can say, while choosing the sound. So some formats are less compression, some formats are of uncompressed, some are compressed. So various kinds of formats are there, and while we choose audio tracks to upload the track, or we don't have to download the audio track, there are a few things that we have to keep in mind. So we will be discussing the concepts about the audio file formats in this video. The major things, the topics that we'll be covering in this video, that will be the audio and the audio file format, codec, what are the codecs that are used, three categories of audio format, audio files, what are the uncompressed audio files. We will be also discussing about the features of the uncompressed file format. There are lossless compressed audio formats. We'll discuss about the feature of lossless compressed audio format. We will be also discussing about the lossy audio format, the features of lossy compressed audio formats, the most common format, that is MP3 and the wave. I think each and every one of us know about the, even if you do not know much more about the MP3 or the wave, at least we have heard about these tracks, because these formats, because these are the formats that are very commonly used. Even if you have to download the music of a latest Bollywood Hollywood number, then we have to, when we go for the MP3, because it has very less space, it carries very less space in our cell phones. So we generally use this, although it's a very compressed format, so but still we use wave, WAV. This extension is .wav. This is very, again, for famous format that wave we use if we have to record or we have to send our audio file without compress in format. So we generally use, so we'll be discussing this thing, and later we'll be discussing about the what are the frequently asked questions in this audio format topic. So we'll be covering all those things. So let's start with the interesting presentation that I have with me for you. That is, let's start with that, this audio file format. This, you can see in the first image, it has a lot of files format, but we will not be discussing about each and every file format. But just for your general information, you should have at least the idea about what are the file formats that really exist. You don't have to go much deeper into these. So let's see that we can see here there is m.mp3. Yeah, as you know, its extension. So dot is the protocol of this file format. This first is .mp3, second one is .amr, third is .ape, this .mp2, next .m4a, next .ogg, and later you can see here .wma, window media audio. This .w .ra, .vqf, .wav, .ac3, .midi. Yeah, we'll discuss deeply about this .midi. What is midi in this video? .3ga dot aiff dot m4r dot aac dot asf dot flac. So we use a lot of audio recording softwares, we use a lot of audio editing software. So many time it happens by default. In some software we get X, or some software we get the Y output. By default there are some audio recording software, they have .aiff. This is also very common format used by the people who are into editing and the other thing. So this .aiff is also a famous format. Generally people use this. So these are the topics that we will be covering: audio format codec, with categories of the audio format: uncompressed, compressed, lossless, and so on. So let's start with the audio and audio file format. What is audio? Audio is an electrical or other representation of sound. That is the audio. Uh, an audio file format is a file format for storing digital audio data in computer. So it's very simple thing about the definition. Actually, you should know about the definition of the audio for the exam purpose. You should learn these definitions by heart. Audio is an electrical or other representation of sound. An audio file format is a file format for storing digital audio content data on your system. It can be raw bit stream, but it is usually a container format or an audio data format with defined storage layer. Yeah. So I said we will not be going much more deeper technical into this. So the audio file has the layers that is defined, and each audio file has the data that is stored in that file. So this audio format, or this you can say it's a codec. If you go deeply into the sound engineering, this is the very interesting topic in that. It is important to distinguish between a file format and an audio codec. So this is, you need to know what is codec. Another word, like a codec performs the encoding and decoding of the raw audio data. See, the raw file is what does the raw file means? So we have new three terms. First is codec. We have raw file format, and this we have the audio output. So we're discussing with the about the codec and the raw. See, the raw file means if you have a recorded file, if you have recorded a voiceover, a narration, or if you have clicked the image, if you talk about the raw image file. So after clicking or after the process production, you have the lot of options to make a post production better, or you have the options of creativity. You can do a lot of experiment with that file. So that file is known as a raw file. Raw file means you have the a lot of options to do changes and show you creativity. For example, we'll say if I have a raw audio file with me, so I have the option of adding the background score. I have the option of changing the pitch of that track. I have the option to increase the amplitude of that track. I have the option to add the special sound effect. I have the options to change the wave or make some changes in the audio wave format. So that is the raw one. So a raw have these all options. So if you talk about the codec word performs the encoding and decoding of the audio raw audio data. So if we have recorded any raw audio data, and if you cannot access the because it's not the finished product outcome that the common people can listen. So we need to convert that audio raw audio file format after adding some special things to that. So the process of encoding and decoding raw audio data, while a data is stored itself in a voice file, you can say that's a codec. So a codec performs the encoding and decoding of the raw data file, while the data itself is stored in a file with a specific audio format. The data does not change. The data is there. Some more inputs you can see in that. You can feel, you can listen in that format. In other words, if you see a codec contains both ADC and DAC running off same clock. We'll discuss this later, ADC and DAC. So there's a small flowchart. You can see it starting from like audio source. The first step is audio source. The second step is audio acquiring. Okay, so audio acquiring. The third step is audio processing. The fourth one is audio encoding, and the fifth one is audio output. Let's say, for example, I have recorded my voice over in studio. So I'm the audio source. I'm recording the audio source, and audio acquiring is the process. Is like you can say it's a mic, and that is acquiring the audio, and then audio is processing that same thing. That software which is used to record the track, that is recording. When I'm saying, the waves are created in that software, and the track is creating, so that is audio is processing. And after the processing, when we save the file for the export, the thing is like audio encoding process happens. Then that is the fourth step. Encoding process happen. Then afterwards, encoding, the output, audio output, we get after exporting the track, the final export outcome, that is the audio output that we are getting. So this is a small process of the audio encoding there. So let's see the three categories of the audio files, the three categories in which a certain audio file belongs to. What are the three categories? The first category is uncompressed, the second category is lossless, and the third one is lossy one. So the first is uncompressed, second one is lossless, and the third one is lossy. So the third one, that is completely lossy. Lossless means loss is there, but less loss is there, so it's not like a full loss. You can see there. Okay, so the things are like that. So in the first one, the we have uncompressed one, that is the WAV wave we have with us. So even if you are recording 5 second or 10 second of the audio track, but that if you're recording that in WAV format, so in the wave format, so it's a uncompressed format, so it will by default it will be having a very large file size in the MB. Like let's say if you are recording 10 second of the audio file, then if it is an MP3, then it can be in KBs. But if you are recording that same file in the .wav, then it will be in the MB and megabyte. So this uncompressed, this wave WAV is the example of uncompressed format, that is wave. So these files generally have a large file size, and they are not compressed, they are raw, you can say. Yeah, for example, if you're looking for the raw audio file format that I have discussed, the raw dot wave is the one of the format of the raw audio data file. Second one is lossless file. Lossless, if you see here, audio files that are compressed but does not lose any data to a file. You have option of, like example, let's say WMA, the video media audio. These files, you can see it is lost. It has loss less compression. Loss is there, but very less, and you are not losing any quality of the audio track in that. So although files are compressed, but you're not going to lose any data in that. The third and the final last one, that category of the audio file, that is lossy. The audio files, the one of the best example of lossy compression is that is MP3, famous format that we access in our cell phones. We use format in our for the podcasting, and the other way we use, it's very common format, and that can be accessed in anywhere, anytime, any device. So audio files that lose some quality when being compressed. So the MP3, you can say, if you have recorded something, so by default it will record it in the wave format, and later you are converting wave to MP3. So converting from wave to MP3 is like you are losing the quality of the audio track. So things will get changed later. Let's see uncompressed audio formats. So there is one major uncompressed audio format, PCM, that pulse code modulation. It's a process which is usually stored in a .wav file on Windows or in a .aiff files on Mac OS. So this Mac OS format, this pulse code modulation PCM, it's a method used to digitally represent sampled analog signals. So sampled analog signals is again PCM is it's a method used to digitally represent sampled analog signals. It's again a technical thing. The BWF, that's a broadcast wave format, is a standard audio format created by the EBU as a successor to wave. BWF allows metadata to be stored in the audio file. Let's see the features of uncompressed file formats. WAV and AIFF are flexible file formats because they are flexible because they're designed to store many more, like more or less any combination of sampling rates or bit rates. This makes them suitable file format for storing and archiving and original recordings. Original recordings are used to change, used to make creativity, and used to mix the song. And if you're producing any sound, you need to have the raw file or the original file so that you can make a lot of changes in that. You can change the things to create your track. So the examples of uncompressed file formats, that is wave, AIFF, the variants of AIFF is .aif, AIFC. Again, the third is AU, the variants are .au and .snd. Raw headerless PCM. Let's see the lossless audio formats. Lossless audio formats that I have discussed, WMA, that is media audio. So a lossless compressed format stores data in less space by eliminating unnecessary data. So here again it is eliminating the unnecessary data, but storing the data in less space. So this will have data stored less, it will have a file size less than the wave and more than the mp3, because it is removing the data, but it is not removing the all the data, it is only removing the unnecessary data while compression. So it is lossless compression. Uncompressed audio format encode both sound and silence with the same number of bits per unit of time. So that's why it's like this is a feature quality of the lossless formats. The uncompressed audio formats encodes both sound and the silence with the same number of bits per unit of time, but in this less compression they do not encode the silence. So this is somewhere you can see, check the it's unnecessary data, silence is unnecessary data, so it removes the data of the silence. In a lossless compression format, the music would occupy a small portion of the file and the silence would take up almost no space at all. So that's why mp3 are the very famous in music world. In mp3, if you talk about the mp3, it's again a different thing, but if you talk about the lossless compression format, that like wma format, and if you talk about the music, any music, Bollywood or Hollywood number or track we have, and that is in WMA format, the lossless compression, it will occupy a smaller portion of file size, because the silence that would that take up almost no space at all. So that's why that in our music industry, like file of the music or track, that will be of less size. And now let's see the feature of lossless compression, compressed audio format. Lossless compression format enable the original uncompressed data to be recreated exactly. They provide a compression ratio of about 2:1. For example, FLAC flag wave pack .wv, monkeys audio .ape, ALAC, Apple lossless .m4a. If you talk about the lossy audio formats, lossy audio format, lossy compression enable greater reductions in file size by removing some more data. Lossy compression typically achieves a far greater compression but somewhat reduced quality than lossless compression by signifying the complexities of the data. So this is the unique thing in the lossy audio format. A variety of techniques are used. Variety of techniques are used mainly by exploiting psychoacoustic acoustic to remove data with minimal reduction in the quality of reproduction. Features of lossy compression audio format. Most formats offer a range of degrees of compression, generally measured in a bit rate. Lower the rate, smaller the file size, and more significant the quality losses. So this is very general thing. If you talk about the MP3 format, uh, they offer the degree of compression generally measured in that bit rate. So with the lower rate, the file size will be small and more significant. The quality loss will be there. For example, MP3. For example, we have Vobis that's in the format .ogg or OGA. If you talk with, we have the musepack.mpc or .mp plus or m.mpp. We have .AAC. So AAC we have the variants .m4a, .m4b, .m4p, M4v, and so on. Then we have AdTrack, that's ADRAC. We have .AA3, .OMA.AT3. We have Windows Media Audio Lossy, then WMA Lossy, and WMA we have. So most common audio files that generally we hear in our iPods or iPods and the like music players, MP3 portable music player. That the MP3 is the most common audio format, the most common type of the audio format that we still being used today because technology is changing day by day. A lot of new advancement and new creations are being found in the technology, but still it's been more than a decade that we are using .mp3 format still now. Wave files and mp3 files are also used. Waves are also used many times in the mp3 players, but the mp3s are the files that are most popular because it is used for downloading and storing music into your computer, CD player, or mp3 player. If you talk about the wave files that are used for storing CD quality sound file, which can be large. But if you talk about MP3, the file, the same track, 22 minutes, we have soundtrack of 5 minutes in the wave, or we have 5-minute sound of the track in the wave format or in the MP3 format. So the file size will be very less in MP3. So generally we use MP3 format for the audio to store data in our portable MP3 player or the iPod because it is carrying less space and we can utilize the same space in storing more audio file. But if you have to record the quality sound in the CD track, then generally we or in the other place on the cloud, then we generally we go for the .wave format. Wave format, wave means storing a pattern of music signals in digital wave form on computer. So we are storing the pattern of music signal, the wave that is creating the we are recording, we are saving the pattern in the format. We cannot go deeper into the file. We can't see the file from the outside, but when we'll import that track in the some audio editing software, then we will be able to see the track, the wave more clearly. So this means they can store any sound. That any sound can be stored in the wave format. If you see the wave, then any sound can be saved. However, the sound files are huge and process over 160K kilobyte per second. So this is a very large, huge thing at 160 KB per second. That saving the process is one. So this is the heavy one that was compared with the MP3. These files can be seen with the suffix of .wav. Like for example, if I have the file name Fred, so it will be like FRED Fred.wav. So by seeing the format, that's where we can easily identify about the file format. Let's see about the mp3, mp3 or mpeg level 3. So mpeg level 3, that indicates a file type of sound file found on the computers. mp3 is designed to store music at cd quality, but using approximately 1 by 12th of the space. So this is one of the unique thing of the mp3. But nowadays, you see, we are not using cds, we are not using dvds, we are not using like hard disk or the pen drives also nowadays. So things are getting online. We are using cloud technology, we are streaming things online. So so mp3 generally is used to store the thing. If you should look go for the streaming audio track, that's a different thing. But if you are storing the files for the offline track, so we generally go for the mp3. And mp3 just this is the this is this space stores the space that's approximately 1 by 12th of the total space. This compression method is perspective encoding. So this means that approximately 90% of the music which human ear does not respond to, that is duplicate notes, quieter sound, that is removed. So the that portion is removed. So that's why this has this unique quality. Now, if you will compare the MP3 file and the WAV file, if you will do the comparative analysis of the both the formats, so you will find some interesting things like, and this is the WAV format and this is the MP3 format. So thumbnail will be almost similar, but just change of the name WAV and MP3 will be there, but thumbnail will find the same. In MP3, you'll find the 44 kilohertz compression and 16-bit and 128 kilobits per second transfer rate. But if you talk about the wave has 96 kilohertz, 24-bit compression and 4096 kbps transfer. Here I have done a comparative analysis of the properties of the file. I have one music file that's of 1 minute, that's of 40 seconds, 40 to 60 seconds. So I have just right click on that file and I clicked on the property. And after clicking on the property, what I saw is there, you can see right now in front of you. In the first one, that I have the properties of the mp3 file. In the first file, the file name is music, music. So the file type, this is mp3 format. So this mp3 format file, so this file is having a size of 124 kb. The size on the disk is 128 kb. So see, this is having a 40-second audio track with file name music is of 124 kilobit per second. When if we see the same track in the wave format, that is uncompressed format, the same file that is on the right side, you can see the music, the way that's in a wave format, and it is of 1.32 megabyte MB. So see the difference, it is 124 KB, very less, and the right side file, that is 1.32 MB. So see the difference. The MP3 format is very compressed. The data is lost. Like many data is lost. So that's why the file size is also very much less in the left one, that is MP3. And if you see the wave, it is uncompressed. So that's why the file size is more. So this is, you can compare the file size and get the idea. If you're in 1 MB, how many MP3 files you can save of this 40-second music track. Let's see this MIDI, that is again a format. MIDI stands for the musical instrument digital interface and is used with the computers. We are connecting the instruments like the keyboard, the piano with our systems. This has CD stores sound music. MIDI is a manuscript version. It also involves hardware within the computer, including cables, keyboard, computer sequencer, synthesizers, instruments, etc. It stores pitch, volume, which instrument is being played. For example, if I'm playing a keyboard, a piano, so it's saving the in it's recording in MIDI format. So it's recording the pitch, it's recording the volume, the tone, the whatever the properties of the sound input is there, the output will be get the same output with along with storing its data. So MIDI comes from the notation side of music and is best thought of in terms of an orchestra or score where a lot of different instruments can be put together in one entity. So let's see some frequently asked question. Generally, when we talk about the audio formats, so we have a lot of questions in our mind. So these are the few frequently asked questions by the students. So let's discuss these questions. The first one is, what is the best audio format? When you go record the file, when you export, and you go for the podcast. Tell me one major question, one very common question that comes to our mind. What is the best format? See, format best, you have to choose the platform and you have to see the what are the hardware that you are using and what are the software that you are using. You have to see that also. Unless you are editing the audio, you don't need to store the audio in these formats. Okay, in the format that is FLAC, the free lossless audio codec. This is the most popular lossless format, making it a good choice if you want to store your music in lossless. You can go for that. Unlike Wave and AIAF, it's been compressed, so it takes up a lot less space. So the second question is, what is the most common audio file format? So the best and the most common. So generally we people say go for the best, or generally people go for the, so best one is this, but generally do not people everyone do not go for the flag not FLAC. People generally go for the wave or generally go for the MP3 format. So these two common formats are that dot wave and the dot MP3. Very common form. These are not the best one. These are the common one, you can say. But if you see the best and the common both, yeah, wave is the best and it's the best also. It's a commonly used format also. The WAV format is widely used on the MP Windows based machines, including PCs, tablets, and phones, and on the Android phones also. And is a good large format audio file. So possibly the most common use for WAV file is creating CD quality music. But nowadays CD is obsolete, so people generally don't go for the CD. What is the highest quality audio quality? So this is where high resolution audio comes in to illustrate why it should sound better than MP3. For example, let's compare the relative bit rates. So the highest quality MP3 has the bit rates of 320 kbps, where a 24 bit and 192 kilohertz file size has a data rate of 9216 kilobit per second. So this is a difference you can see. Music CDs are like generally 100 for 1411 kbps. The next one, what is the best quality music format? So best quality music format and the highest quality audio. So there is no one clear answer to what is the best file format for the music playback is, and the quality mastering of will sound also makes a bit impact on, but there are many format that audio files tends to use more over than others. FLAC and the MP3 over 320 kbps are the most commonly used in the audio file community, and what I use personally use myself. Next question, is 24-bit audio better? The most bits, the greater dynamic range of sound, of soft to loud sound that your audio file can have. There are basically two audio depth measures in use today, 16-bit and the 24-bit. So generally people use these two. So CDs are traditionally produced as 16-bit, while 24-bit sound file are typically used by audio engineers during recording and the production. Next is, what is the smallest audio format? Okay, so .FLAC audio file are free lossless audio codec. It is an audio file compressed into smaller size of the original file. It is a sophisticated file type that is lesser used among the audio formats. Next question, which is better, 16-bit audio file or 32-bit audio file? So if you see, the reason is that converting a 16-bit audio up to 24-bit or 32-bit has no negative impact on sound quality. So there is no reason not to set it to the highest. Set the sample rate to match the sample rate of what you listen to most often. CD audio and most music is 44.1 kilohertz. That is probably the best choice. Is AAC better than MP3? AAC, that is advanced audio coding, and MP3, that is MPEG-1 audio layer 3, that are lossy formats. Both are lossy formats for audio file, designed to be the successor of the MP3. AAC generally achieves better sound quality than MP3 at similar bit rate. This difference in quality is more obvious at lower rate. Which is smaller, MP3 or the wave? So wave files are much larger than the MP3. I have already discussed, sometimes up to 10 times more larger than the MP3. So wave files are much more heavy. The wave file format is an uncompressed format, while MP3 use compression methods to decrease the file size. Wave file can be supposed to be better sound quality, but they are much larger. Does Spotify use AAC? Spotify, again, podcasting app, famous podcasting app. So does this support the AAC? Sound quality is usually better than Spotify's, thanks to Apple using Apple Music using a 256 kilobit per second AAC bitrate compared to the max 320 kilobit per second OG Vobis bitrate used by Spotify. So this iOS and Android desktop apps are myself least favorite user music streaming interface. So there's a chart you can see, compare the like how many MBs. All of these questions are a little silly, but they are logic. They have some logic also. Like how many MB is 1 hour audio? If I have the audio track of 1 hour, that is of 60 minutes. So how many MBs that file will cover? Question generally comes to our mind. If I'm recording this track of this minute, so what will be the space it will be covering? So here is some chart table. You can see it's a bit rate, file size per second, and the file size per hour. So if you are recording the 128 kilobit per second and the file size per second, that's 16 kilobit, so the file size per hour will be 57.6 MB. Similarly, 160 KB bitrate, so the file size per second will be 20 KB, and the file size per hour will be 72 MB. Similarly, if you see how big is a 2 hour audio file, so the if you see in the calculation of the MP3 files, you don't have to go much more deeper. It's just for your general information. If you do calculation on the basis of the MP3, MP3 files is a very small size. So if you have 2 hours of audio file, that is of 120 minutes. So what will be the how big the file size in the MB in the MP3? So the formula is you can see it's a formula. So if you see in 8 kbps, a file size is 1 KB. The file size per minute will be 60 KB, and file size per hour that will be 3.6. So you cannot give a exact a similar like a single answer how big my file size will be if it is of 2 hours. So you need to know about the bitrate also, and you need to know about the file size per second and file size per minute also, to get the exact idea about the how your file size is going to be big in 1 hour file audio track in MB. So you need to know about the bitrate and the file size per second also, to get the exact idea about the size of your audio file in of 2 hours of track. So thank you for watching this PowerPoint presentation. I hope you must have got a lot of new ideas, things about the audio file tracks in this video. If you have liked the video, I hope you must have liked this video. If you like the video, so please like, share, and subscribe this video. And still you have any questions, you can ask your questions in the comment section. I'll try to answer them. So please be in touch. And thank you for watching this video. This was Rabinshu Sharma.